Okay, then are you still there?
Yes.
Okay, yeah, Wi-Fi is a bit unstable today, so it keeps crashing. So just bear with it for a while. As I was saying, is there any question from question 1 to 9 of the homework, guys? If there is a question that you cannot do, now is a pretty damn good time to raise up your hand. Do you watch the video, by the way? Okay. You're gonna struggle like crazy today then. I sent you guys the video also, right? Did you watch the video? No. Did you watch the video? No. Did you watch the video? No. Four of you guys are gonna struggle like crazy today. Okay, now, questions for question number 1. Anyone can do question number 1. Shut up, listen. Yeah. Question number 1, everyone. Question number 2. Question number 3. Question number 4. 5, 6, 7, 8, 9. Anyone wants to ask? Hey, if you do, okay, for everyone that is relatively new here, this is how things are gonna go, okay? I'm not gonna be like your dad. I'm not gonna be like a school teachers, right? This is like literally a free society kind of learning experience, okay? Free society, of course, there are some rules lah. Number 1 rule is shut up when I'm talking, okay? And number 2 is if you don't ask questions, I really cannot help you. If let's say listen up, okay, before you continue wasting your money and your time and your parents' money and your parents' time. If you plan to sit in this class and think like, oh, I'm just gonna watch a show, bro. Every Saturday there's a physics show going on from 2 o'clock to 3:15. You can go home already. Next month, don't come. I cannot help you. But if let's say right, you say that, but teacher, my dad forced me to be here. I don't really want to be here, and it's hard to debate against him. Then you let me know earlier also. Then I say, okay, in my eyes, you are dead already. You're gone. I cannot help you. Okay. So having said that, what I really want to say is, if you don't ask questions over a long time, you will definitely not benefit in this class. Okay. Good. Having said that, if no one has any questions for the first 9 everyone got it correct already. Those that did it correct for the first 9 questions. Okay, for those who, if you have no questions today, what we're going to be? You have a question? Pay attention. Okay, if you have no questions, guys, today what we're going to do is we're going to be doing exercises today where I'm not going to cover a new chapter. I'm going to give you a certain time frame for specific questions for you to attempt, right? Once you are done attempting, usually I'll discuss the answers and we'll start off with the first 3 A, B, C questions first, guys. You have a total of 7 minutes to attempt the first 3 questions. Once you're done with the 7 minutes, or if everyone is done already, we'll just discuss the answers immediately. Guys, you have a total of 7 minutes to attempt the first 3 questions. You can start doing it right now. And for you, you can chill. The rest of them. If you need help from your friends, please feel free to discuss. If not, don't disturb. Don't disturb the rest of them. Oh, she's not working. You guys well, this empty first books. There's
Maybe both, and we might say he was the master. It's not. Was the last.
Hopefully you guys want to review about it.
Okay. It's better. It's good for. Hey, good.
Do you attend all this on your
Now,
3B wrong? Yeah, 3B is wrong. Figure it out. Read your question. Think about it. It's here too much time right now. Exactly right. Yes.
oh, this. Oh, yeah.
Wrong. Second one.
Very good. But it's all that. Or that we like. If the market. Did you?
Yeah.
The name of the. The red.
That's probably the end now. Guys, for those who have absolutely no idea what's going on, guys, maybe now would be a good time for you to copy down the formulas first, guys. You're supposed to use the formula of change of momentum. Yes, refer to the notes, Alia, you were here. Guys, you have 2 more minutes to attempt the first 3 questions. If you're done with the first 3 questions, you can actually attempt the next few ones. No, initial. Mu is initial, V is final. Good. Huh? What's B? Alright guys, let's go through the questions together, guys, and okay, everyone, I need you all to shut up, listen up. Shut up, listen up. Okay, if you look at this first question here, it's a very straightforward one. It says that an object of mass I usually like to label my information from a velocity from, right, so this is initial, right, to a velocity, so this is final, in the same direction, not important. Count what is the impulse provided to cause the acceleration. First question is they ask you what is the impulse. Impulse, there's only two formulas, right? Either it's going to be force times time, or it's going to be change of momentum, which is mv minus mu. And obviously, in this scenario, we cannot use force times time, right? So naturally, we will use this formula, which in this case here, impulse equals to change in momentum, which is 50 multiplied by 10 minus 50 multiplied by 2. And thus you'll get 400 Newton seconds. First question will be B. She copied you, you copied her. So it's like a vicious cycle at this point. Good.
Teacher,
Yeah.
but
Wait first.
I don't know how to
Okay, if you look at the second question here, it's a concept question. Guys, you haven't learned about kinetic energy yet, but I want you to know that energy are basically scalar quantities, guys. Scalar quantities means to say they only have magnitude, whereas momentum is a what? It's a vector. If it's a vector, it means to say it has what and what? Magnitude and direction, right? Now you see here, the key word here is that after the rebound, right, the speed is the same. If the speed is the same, that means to say your kinetic energy is not supposed to change, right? You'll learn this later on. Now, the speed is the same, means to say kinetic energy is not supposed to change. But however, the momentum changes, even though momentum's formula is mv, right? And we say that we have the same speed. How come the momentum changes? Because it is in the opposite direction, which means to say, right, if I associate this as positive momentum, this would essentially be negative momentum, guys. That's why the momentum changes. You understand what I'm talking about, guys?
Yeah.
And finally, the last question here is a very straightforward one, which is the units for NS. NS is basically force times time, which is part of the impulse formula. Anyone with any questions with regards to this? Good. Proceed with the next question, guys. If you have no questions, you can proceed with this next one here. This next one goes all the way until this question here, donkey here, guys. I'll give you a total of... No, it's going to be more. 10 minutes,
Sure.
Once again, for those who did not watch the video, now is a pretty damn good time to copy down the formula.
Total momentum before collision and total momentum after collision is the same, right? So before it's at 0.5 pgs at the of this, right? So this times this basically that's
Correct,
and,
correct.
and then this is the
Yeah.
over here.
Actually,
And then-
it's correct. Your looking was just not right when we before this. I wanted to see this. I wanted to see the 0.5 V plus 0.3 V.
So I was correct.
Yeah. Exactly.
That is so nasty. Forgot about that. I'm looking.
Oh my God, why is it wet here? Oh.
Very 50.
Yeah,
That's a normal age for a young thing. It's not.
it is.
Year 9, not year 10, year 9. Yeah, how is that?
What are you?
The thought never.
You are the normal one, bro. That's why you still got so much energy in you.
Old grandpas. What are you, the teacher?
I'm like Wu Gui, yeah.
Ignorance.
Yes.
Okay.
Oh, guys, I want to remind, I think I didn't say this to you guys yet, guys. But next week, right, my kid is actually coming. So, oh, maybe not next week. Yeah. My wife is probably delivering on the 7th of October. So if she delivers, most likely I'll be missing for a week. Then I'll get someone else to come teach you guys for that week. Yeah, college student with a kid now. No lah, we're a college student, bro. You know how old I am already? Yeah, I'm 32 already this year. Maybe 18. Anyways, yeah, like I was saying, guys, maybe that week I'll get one other tutor to come replace me for obvious reasons. But I'll instruct her to give you guys exercises to do. Yeah, very likely. The what? Who went to Australia?
What? Teachers is like email.
Maria? Yeah. Did she teach you?
Yeah.
Oh, yeah. She left to Australia, but it's not her. It's a different one.
Teacher, I think it's calm down.
But we'll see. No confirmations yet. We'll see.
Teacher. You should honestly crazy setting. I think you should just calm down instead of increasing the expenses based on by unexpected cost. You should just give us. I think it's calm.
The 2 sessions in physics, chemistry. I'm going to have my physics, chemistry in that room.
That's also about how to type.
Good. That's fine. Wow. It's a boy. Is it a boy?
That is a very deep gut question right there.
What? I didn't say anything. I'll never.
Please allow me to do. Huh? It's final and short.
Sure.
30. Oh.
It's the other way around. But you know it's a great book. Yeah. But you don't need negative value. I think that it's not very you know, 100 to change is 100, 100 to 0 to change is still 100.
Teacher. Like, the way you take the, it's closed.
No, you cannot.
Teacher.
I'm not speaking. It's here. This guy is solving. Nice. Yo, fucking bro, I don't
So basically,
Stop.
well, but your no, that's what you like. It's fine.
Well, they follow after.
What? What's the formula for extending
B minus 2D. Please, let's say you get this number. Wait a minute, are you telling me 70 times 0 is 70? Then after this 70 minus this 140 gives you this number? That's not how math, my friend. I've seen enough already. It's not about how you're supposed to do this question, okay? Guys, we're going to discuss this one. Everyone pay attention. So the first question here, they give you something like, it shows a dummy of mass 70 kg. Right, and then the car approaches a barrier at 20 meters per second. It crashes into the barrier and stops immediately. This is your B, right? Which is going to be 0, right? Calculate the momentum of the dummy immediately before the crash. Momentum's formula is mass times velocity, right? Which is basically 70 times 20, right? Which will give you 1400. What's the units, huh? Yeah, you either write kgs meters per second or kgs ms -1 or even if you write kg meters per second also is acceptable. It's all the same thing. Okay, I think first question, everyone got it correct. But the second question is where I start to see some really funny answers already from everyone. What's the formula for impulse again? Impulse has two formulas, right? Either it's going to be force times time or it's going to be mv minus mu, right? In this scenario, which one are we supposed to use? Yeah, so it's impossible to use this, right? So basically, I just substitute the information in, right? It will be 70 multiplied by 0 minus 70 multiplied by 20. And at the end of the day, I'll still get 1,400, even though calculation-wise, I get negative 1,400. Why? Why do I write 1,400 instead of negative 1,400? It's the same. Yeah, I know. Dude, okay, let's clarify that doubt right now. You're thinking that NS is from impulse, right? But impulse has a secondary formula, which is mass times velocity, which is kgs meters per second. In other words, I want to let you all know that ns is the same as kgs meters per second, guys. It's the same thing. And I can prove it to you as well if the time is there, right? But essentially, right, for those who want to have a challenge at home, guys, you want to prove that this is equals to this, right? You ask yourself, what's the formula for newtons, which is essentially mass times acceleration, right? You ask yourself, what's the units of these two multiplied by these thing? These two multiplied by this thing, you'll end up with the exact same units, guys. In other words, this is a basic unit, guys. This Newton is a derived unit, Derived unit means to say it's a combination of a few things and they simplify it using just one letter. You get what I mean? But you won't be tested on this, you just need to know they're the same thing. Yes, but yeah, either one is acceptable. If you write ns or kg meters per second, both is the same.
One question.
Oh, by the way, you haven't told me yet, why don't I write negative here? Even though the answer here is given as negative.
0 to 100 is still 100.
Yeah, listen up, guys. The impulse, right, is defined as the change in momentum, right? Change in momentum, it doesn't matter if I go from 0 to 1,400 or 1,400 to 0, right? The change is still 1,400. That's why we don't write negative here. You understand or not, guys? Yes, moving on. Oh my God, the internet is gone again.
Yeah,
Yes, starting to believe so.
I think
No, stop,
it does.
stop. Then what we're supposed to do? You're asked to calculate the deceleration. What's the formula for acceleration again? Leon, what's the formula for acceleration? Good. Acceleration is v minus u over t, but deceleration will be u minus v over t, guys. So I basically need to find the initial, the final, and the time, right? Which we know that the initial speed was 20, right? The final is 0. And right now we're given the time in 0.2 seconds, right? So it's basically 20 minus 0 over 0.2, which you're going to get 100 meters. What's the units for acceleration and deceleration again? What's the units for deceleration? No, units, not formula. Meter per second? Square. Very good.
Yeah, it's from acceleration. Again, it's fine.
Yeah, but you cannot write negative here. Let's say, for example, you do acceleration now. Let's say if you find acceleration and you get negative here, right? Which is common because negative acceleration is deceleration. But if you wrote here negative 100, negative deceleration is the same as acceleration. So you cannot write negative here. It must be 100 only. Yeah.
So, but if I write
And if you wrote acceleration equals to negative 100, then you know that deceleration is 100. Then can.
the next one.
Say that again. Oh, this part here? Okay, so if they're asking you to find deceleration, right? So you use the deceleration formula, you'll get 100. But if let's say you use the acceleration formula, you'll get basically 0 minus 20 over 0.2, right? Which will give you negative 100. You cannot write the negative 100 here because negative 100 acceleration is basically deceleration. You get what I mean? Okay. Okay. Let's say that today we use this calculation now, right? You found negative 100, right? Is this acceleration or deceleration to you? It's deceleration. Because it's negative. Acceleration is once again a vector quantity. If you find that acceleration is 100 meters per second square, then I know that this object is accelerating. But if you find acceleration as negative 100 meters per second square, this object is actually decelerating. But you cannot write negative here because the question wants for deceleration. You get what I mean? Any other questions? Okay, next, moving on. So right now you're asked to find the force, right? The seatbelt and airbag brings the dummy to rest. Once again, to rest so that it does not hit the windscreen. The dummy has an average deceleration. This is your deceleration, right? The average resultant force you're asked to calculate the average resultant force given the mass as this, right? So right now I have deceleration, I have mass, I'm looking for force. There's only one formula that relates all these three things together, right? Which is essentially F equals to ma, guys. F equals to ma is your general formula for force, and since you're looking for force, it's basically going to be 70 multiplied by 80, which you'll get 5,600. What's the units for force, guys? Don't need to write negative.
Okay.
Okay, and last question, which is once again a concept question now, guys. The deceleration of the dummy is less than the deceleration of the passenger compartment. Explain why this is a benefit. What benefit is this for the passenger, guys? This whole concept here, this whole question here revolves around this answer here, guys. From the previous question, we understood that if the deceleration is 80 meters per second square, I'll apply a force of 5,600 newtons on the dummy. Right now, they say that the dummy has less deceleration. What does that implement? What does that imply? No, in terms of force. There'll be less force, right? Because right now, this dummy is decelerating less, which means to say, right, maybe just now was 80, right? Maybe right now, instead of 80, it's only 40, which will give you half the force only, right? And they ask you to explain why is this a benefit? What benefit does this do to the dummy? You're supposed to say that with less deceleration, there is less force exerted on the dummy. Thus, less damage.
But if I write a car crash, a passenger's momentum changes more gradually than the passenger's compartment due to impulse from safety. These features help increase the time over which the momentum is changed. Thus,
Cannot.
why?
Because there's no time component here.
No,
They have to talk about the deceleration.
increase the time. They don't do the time. Which the dummy is.
No. Okay, guys. Anyone with any questions from this one so far? We're good. 100% absorption rate. Do question 2 right now. How many questions are there? You have 7 minutes to attempt question number 2. Question number 2 is a formula-based question, guys. If you have the formulas, you should be able to do the calculation. Sorry? MU, initial momentum. MV is final momentum. What?
Okay. Right. So it's going to be
Explain this 1,000 times already. It's change of momentum. But that's not the point.
Like intentionally you go every minus and getting the friend. How do you compare it? So the is confident. Wow.
Yeah, it's the base actually. Fast, you can do question number 3 as well. Who's I'm relying on
For maths. Yes, why is it that they have no people there or they think
but the formula will take a momentum right afterwards. That's the formula of momentum, that's the formula of change of the momentum. Yeah. And B minus MU. We got 4. So, okay, is that in all the different okay, which in or and both of them, all this is all very three of the factors would be on time. This function is around the estimated, but because I yeah. And nice. It's very fast and behavior. So like if Yeah, do a good damn job. What the hell is that looking? Looking for force, right? Use the default formula to find force. Yeah, change in momentum is mv minus mu, substitute the numbers in.
What would you do that? And
One and question. And force to give a force, right? And force unit is the thing like E units meter per second. Then after that, what is this and this? Well, since I sharp, I will say you are not supposed to use this. You're supposed to write down the actual formula which has formed. What formula has formed in this volume pulse? Yeah, you're supposed to use that and then substitute the numbers in. Okay, ladies and gentlemen, I once again see. Very good. Guys, I'm starting to recognize a pattern of the same problem across multiple students, guys. Do you know that in calculation question, you're expected to write your working down? And the first thing is you are expected to remember the formula, but I don't expect you guys to remember the formula. That's why the notes are in front, right? You're supposed to refer to the formulas in the notes, right? Then from here, the first question is they ask you for change of momentum. Hey, listen up, for those who cannot do this question or you took like the whole 7 minutes to do this question, listen up, this is your thought process. The thought process is momentum is mass times velocity, right? Then change of momentum should be final momentum minus initial momentum. Right, from here, your thought process, since you understood change of momentum is mv minus mu, you just identify the information. This is your m, this is your v, this is your t, and then the hammerhead stops. Oh shit, this is your u, right? Yeah, shit, this is your u, and this is your v, which is finally 0, right? So from here, you just need to literally substitute in the number only. Mathematics, guys, 0.15 multiplied by 0 minus 0.15 multiplied by 8. And then you're going to get a negative 1.2 kgs meters per second. But you're not going to write negative here because change is the same. It doesn't matter from 0 to 1.2 or 1.2 to 0. The change is still going to be the same. Yes, then after that, the next question, oh, look, it's only 1 mark and they ask for impulse. Then you realize that, oh shit, my teacher has been saying this for the 6th time now. Impulse is the change in momentum. And thus, no working required. And you'll get 1.2. And finally, for those who are struggling with question C, guys, you're asked to find the force, right? Let's imagine today you don't know anything at all, right? But you have the formulas, you don't know anything at all. You're asked to find the force, right? So you just scroll back to the back and see which of these formulas has force in it. Got force? No, definitely not going to be here. Got force? Hey, got force here. Maybe I can use this. But wait a minute, I already calculated the change in momentum, man. So how do I find the force, Alia? I have the change in momentum right now. How do I find the force? How about you, Sharon? How do you want to get into the test? How do I find force with this formula here? I just calculated change in momentum. That's correct also, but not what I'm looking for. You, how do I find the force here right now, given the change in momentum? Shut up. That's the change in momentum, correct? How do I find the force? Guys, everyone pay attention, okay? I hope this is the first and last time I'll have to teach you guys. So you're looking for force, right? Everyone pay attention now, for those who cannot answer one especially. You can't looking for force, right? So I know I'm looking for force. But I'm already given the change in momentum here already. The full formula that has force in it is Ft equals to mv minus mu, right? If I already have this, don't I just need to rearrange this algebra and make it Ft equals to mv minus mu over t? Right? Then after that, I found that, oh, my change in momentum is 1.2. I just need to know my time only. How much is my time? Hannah, how much is my time? How much is my time based on this formula here? A specific number? And thus I substitute the information in. Hey, do you guys actually understand what I'm talking about, by the way? I feel like I'm not getting through with you guys, and the answer will be 8,800 newtons. Hey, seriously, do you guys know what I'm talking about?
Yeah.
Except for you. I'm okay with you also. I think you guys are fine. But the girls especially, you guys
Be very sensitive.
shut up, shut up. You guys understand what I'm talking about? Seriously, you need. This is just like one part of the calculation. There's like going to be more and more and more and more. Okay, lah. Huh? If you have no questions, please try to attempt question number 3 as well. You have once again. What?
You're done.
I got it.
You're done.
Okay, shut up then. By all means.
305. That's it.
Guys, for those who don't know how to start again, it'll be good to write down the formula first. Enjoy, you're done already. Show me your working.
Actually, I not give you a working. It's that one liner like mine.
If your answer is correct, you can go. You can go.
Eugene, come, please.
The second one is wrong. Do it again. What? Show me your working. Okay, good. You're done. You can go. No, do it yourself. After this time, that's just one process. So that's really thinking. Yeah. Yes, write the formula as well on top of it. And for those who are attempting the last question, once again, you can copy this down on your notes. You'll definitely need to use it on the last question because yes, you can you. Our information is spot. Where it is? Where it is in the diagram? In the diagram, which part of it? Yeah, I think it's my favorite. And this thing was 0 Yeah, okay. I don't like looking to speak on this calculation right here. You're supposed to use the principle of conservation. So, it's the same fault. You're supposed to use this formula. Good, you can go. Congratulations. You earned your freedom. Who else wants to earn their freedom, guys? No, don't help. You have to stay here all the way. All right. Now we can do the second question. Oh, very good. You have earned your freedom. Congratulations. Okay, this one, let's go on. Now, right. Momentum ball. Oh, what do you need? Because it's complex together and this for momentum. So if they're all like, well, they learn that we don't really know it. Going really before. Yes, I am. How can I help you? No, we do. It's nothing. Now I understand here. You're not doing that. I'm going to ask. Oops. What's the final velocity of the first object? What's the final velocity of the second object? And I know that. What? ChatGPT say you're in the room. I'm curious. What do you think your feel about it? Yes, oh yeah. It's
Big.
What is this? Okay, let's assume that I'm standing as that. This thing you tell me you are right, and I'm your philosophy is not this what we feel are right. Read the question again. this momentum before collision, it means to say one perspective of what's 0.1.
No, it's not. Is it zero?
It's out.
Is it one?
Me no. Hey, hello, my friend. Oh, the guys actually calling. Okay, guys, girls, let's pay attention to how we actually solve this question, okay? Okay. Hey, guys, I find that you guys don't want to follow my step by step from the previous few questions. You should have asked. But anyways, let's go through it, okay? Guys, if the first thing to do in physics is always to extract information from the question first. So from here, it says that an engine has an unpowered toy train, is rolling at a constant speed on level track as shown in figure 3.1. The engine collides with a stationary truck and it joins with it. Do you know that when it joins with it, it's basically like the movement is going to collide, then they join and they move together, you know? This scenario is what we call inelastic collision. Okay, inelastic collision, which will actually change the formula a little bit. Okay, once we have this information, it says that before the collision, the toy engine is moving at 0.3 meters per second. Usually, as soon as I extract the information, right, I like to draw it on my diagram because I can actually see what's going on, right? And the mass of the engine is 0.5 kg. And then the first question asks you is to calculate the momentum of the toy engine, which everyone did. Congratulations, at least everyone got this correct. Momentum's formula is write the formula down, mass times velocity, which will be 0.5 multiplied by 0.32. And then if you press it in your calculator, you'll get 0.16. Okay, now my next question is, Elizabeth, what's the units for momentum based on this calculation? Good, it's kg m over s, right? This is the first information. Then after that, it says that the mass of the toy truck is 0.3 kg. Right now, this thing is 0.3 kg, right? Using the principle of conservation of momentum, which states that the total momentum before collision is equals to your total momentum after collision. Calculate the speed of the joint engine and truck immediately after the collision. So basically, after they join together, right, how fast are they moving? I don't know. I need to calculate it. So based on the formula itself, right, based on this understanding here, that principle of conservation of momentum states that total momentum before collision is equals to total momentum after collision, then the formula will be this all, m1u1 plus m2u2 is equals to m1v1 plus m2v2. All right. Then after that, it means to say I need to find what's this, and what's this lah. All right. So from here, okay, let's identify this as object number 1 and this as object number 2. Right. So from here, I actually know that M1 is going to be, how much? 0.5. And then multiply by my initial velocity, which was 0.32. Multiply by my mass of my second object, which is 0.3. Right? This is my M2, right? Multiply by initial velocity of the second object. Was this thing moving initially? No. So it's going to be a 0 here. This part is this part. Total momentum before collision. Then the next part here, this will morph a little bit. Why? Because right now it is inelastic collision. Inelastic collision means to say there will be no longer two different speeds, right? If let's say the object hits it and both of them still move at different speeds, then there will be V1 and V2. But right now these two objects hit and they stick together and they move together, right? So mainly to say there will be no longer V1 or V2, right? It will just be a common V in between them, right? Which then I just put in my number. How much was my M1 again? What? 16. M1 more. Mass 1 more. Multiplied by V, right? And then my mass 2, 0.3. Multiplied by my V. From here, it's algebra time, which I know some of you guys also struggle. Let's do it together. Okay, this one is basically the one we calculated on top to be 0.16 already. Right now, 0.16. These two things add together. What will it become, Hannah? 0.5V plus 0.3V. What will it become? Yes, good, Elizabeth. And from here, how do we find V? Lisa, how do we find V from here? 0.16 equals to 0.8V. How do I find V? What divided by what? 0.8 divided by 0.6 or 0.16 divided by? Ta-da! Then you get your V. Then you calculate, you'll get something. What's that something? The units are very far. Was this 0.2? Meters per second. Ta-da! Guys, that will be it for today, guys. If you want, you can enjoy with them in the switch room. For those who are coming back for chemistry, we'll start at 3:30. Oh, and all of you guys, which I assume did not watch the video yet, go back home and watch the damn video. All of you guys. You too. Okay, I'm gonna stop class here. Bye, Caden. Bye, Max.